Good morning, everyone. Happy Monday. I hope you all had a fabulous weekend, took some time to relax and spend some time with your families. Maybe got a little bit of fresh air. We are starting week 5 of distance learning this week, which I cannot believe that it has been 5 weeks. I miss you all terribly. I was so sad to hear that we will not be going back to school, but I am excited that we have a few more weeks of learning at home for you guys to continue to grow those brains. So you're doing a fabulous job. And I am so proud of the work that you're doing, and I can't wait to see all the great work that you continue to do through the next 6 weeks of learning at home. So today's work is going to look very similar to the work in the week 5 packet. So those of you who are able to get packets picked up from the school, we're going to use the week 5 math packet this week. This lesson will cover day 1 and day 2. So don't feel like you have to do them all today, but I will not do another lesson tomorrow. So this will cover day 1 and day 2 of the week 5 packet. So if you see the same problems in my independent practice in this video as you will in there, there's more in the packet that you need to complete, but this is a good start. If you do not have the packet, don't worry about it. Just do the video as normal. Use notebook paper, send me pictures of your work. Everybody will need to complete the exit ticket problems and send me those over because they're not in the packet. But you will see that the work is very similar to the work in the packet. It's just meant to help make the packet a little bit easier for you guys to navigate. So I am going to share my screen and we will get started. One second. So today we're going to look at equivalent fractions, how to find them using multiplication and division. Here is our spiral review for today. So again, as we work through the PowerPoint, if you see a slide that has a stop sign, that means pause your work, pause the video, take time to work out the problems, and then resume it as soon as you finish the problem so that you can see the solutions and how I solved them. All right, sorry about those technical difficulties. So we are going to start with find the product of 56 and 93. Find the product means find the answer to the multiplication question. So I'm going to multiply these two numbers together. 3 times 6 will be my first product. 3 times 50, because that 5 is in the tens place, will be my second product. Now I'm going to move to my 9, but it's actually 9 tens or 90, so it'll be 90 times 6 and 90 times 50. When I work through those problems, I'm going to get 18. 3 times 5 is 15, so 15 tens would be 150. 9 times 6 is 54, so 54 tens would be 540. And 9 times 5 is 45, but that's 45 hundreds because there is tens times tens. 8, 10, 12, 5. Give yourself a check if you had 5,208 as your answer. If you didn't, go ahead and look through my work and try to locate your mistake. Think about what you made that mistake on so that you're less likely to make it again next time. Good job. Moving on to the second one, the 6 in 36,047 is blank than the 6 in 34,607. So let's look at the 6 in the first number. That 6 in the first number is in the thousands place, so it has a value of 6,000. That 6 in the second number is in the hundreds place, so it has a value of 600. So I see that this 6 is one place bigger than that 6, and we know that the place value chart works by tens. So as we move one place over, we're multiplying by 10. I also know that 600 times 10 is 6,000, so we would say it is 10 times as much. The place value chart works in tens. Give yourself a check if you had that. And our last one is to identify the prime number in this list. So we're going to think about what is the definition of prime. I want you to take a second to say that out loud. What is the definition of a prime number? A prime number is a number that has just two factors, 1 and itself. So that means the only way I can use multiplication to make that number is 1 times that number. If there's another multiplication facts that work, then we call that a composite number. It has more than 2 factors. So let's look at 9. To make 9, I can do 9 times 1, and I can also do 3 times 3. So 9 has 3 factors, not 2, so it is not prime. 9 would be composite. Let's look at our next one, 6. I could do 6 times 1 and 3 times 2, so that has 4 factors and is a composite number. Let's look at 7. The only number I can skip count by to say 7 is 1 and 7. So there's only 2 factors, 1 times 7. So 7 is prime. Let's check 15 just to make sure there's no other answers. 15 can be made with 15 times 1 and 3 times 5. So it has 4 factors and it is not prime, it is composite. So 7 would have been the correct choice here. Great job. As always, go through, think about those mistakes. If you have any questions about any of those problems that you weren't able to identify your mistake, give me a call. I'm here. I'm going to come back to sharing my screen so we can look at today's application problem. And we have a recipe calls for 3/4 cup of milk. Sasha only has a 1/4 cup measuring cup. If she doubles the recipe, how many times will she need to fill the 1/4 cup with milk? Draw a tape diagram and record as a multiplication sentence. So I want everybody to pause, work this out, and resume when you are ready. All right, so I'm seeing tape diagram in the definition, so I know I'm gonna have to draw a picture. So let's look at this. A recipe calls for 3/4 cup of milk. So I'm going to draw a tape diagram and shade 3/4. That's what the recipe calls for. But it says that Sasha's going to double that recipe. So I'm going to do it again. She needs 3/4 again. And she only has a 1/4 cup scoop. So I need to figure out how many 1/4 are in 2 sets of 3/4. So I'm going to just go through and label. This piece right here was 1/4, 1/4, 1/4. So was this one, but I'm not going to write anything there because I didn't shade that in. I'm not using that 1/4. 1/4, 1/4, 1/4. So if I were to write an addition sentence to help me solve what Sasha needs, I would write she needs 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. So I can see that Sasha needs 6/4 of a cup. But it also asks me to write this as a multiplication sentence. So I'm going to look and say, what number do I see repeating over and over and over again? I see 1/4 repeating over and over again, and I see it 1, 2, 3, 4, 5, 6 times. And the question asks, how many times will Sasha need to use her 1/4 cup scoop? So if I look at this multiplication sentence, it sets up that answer beautifully for me. She's going to need to use her 1/4 cup scoop 6 times to get enough milk for this double recipe. So Sasha will need 6 1/4 cup scoops of milk. Looking back through the directions, it asked for a tape diagram. We had it. It asked for a multiplication sentence. We had it, and it was a word problem, so we knew we needed to answer our question in a complete sentence. Hopefully your work looked something like mine. If it did not, as always, go through, find that mistake, think about where you went wrong, and keep working hard. All right, I'm gonna stop sharing my screen, and I am going to work through some of this mini lesson. So reviewing how to use multiplication and division in order to find equivalent fractions. So in order to be successful today, we need to remind ourselves, what are equivalent fractions? So I want you to say that out loud to yourself. What is an equivalent fraction? Equivalent fractions are fractions that represent the same amount. Fractions that are the same amount, but the sizes of the pieces or the scoops or the amount we're running or whatever our denominator is might be different, but we have the same overall amount. So let's look at this fraction here. What fraction have I shown in the picture? I have shown 1/3. If you watch my marker very carefully, all I'm doing is drawing a dotted line. I didn't do any shading, I didn't erase anything. So now I have 2 shaded parts out of 6 total. So we know that 1/3 is equivalent to 2/6 because I didn't shade or erase anything. All I did was cut the pieces differently. I can use multiplication to show this, as we remember, by doing times 2 over 2. I cut each of those pieces that I had into 2. And remember, this has to be the same number in the numerator and the denominator because it means we're multiplying by 1. When I multiply something by 1, I don't change its amount. It stays the same. It's just going to look different. So when we multiply, we can't do times 3 in the numerator and times 4 in the denominator and say they're equivalent because that's not multiplying by 1. To make equivalent fractions, we multiply by 1 in the form of 2 over 2, 3 over 3, 5 over 5, whatever fraction equal to 1 we happen to be using. So let's see if we can find another one that's equivalent to 1/3. So that time I just used 1 dotted line. Let's look at what would happen if I used 2 dotted lines. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 total pieces now. And 3 of them are shaded. So let's check this with multiplication. I multiplied 1 by 3, and I multiplied 3 by 3. So I multiplied by 3 over 3, which is equal to 1. So I'm correct in thinking that 1/3 and 3/9 are equivalent. Now let's try to find one more fraction that's equivalent to 1/3. We could keep going. You could end up cutting this 7 times. It's not a realistic way to do it using a picture, but I could multiply by 7 over 7, 8 over 8, 100 over 100. Those are still equivalent fractions. We're just going to work with some easier to model numbers right now. So instead of 2 lines, this time I'm going to do 3 lines. 1 line, 2 lines, 3 lines. And I've had 1/3 to start. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And 4 of them are shaded. So I multiplied 1 times 4 to get 4. And I multiplied 3 times 4 to get 12. I multiplied by 4 over 4. And 4 is also the number of rows. Here, 3 was the number of rows, 2 was the number of rows. That's how I knew what to multiply by in my picture. So that is how you use multiplication and a visual model. You can use either, that's helpful, to find equivalent fractions. Our work can be taken one step harder by asking us to do some deeper thinking about this work. So let's look at this fraction. 5/4 equals 15/16. It asks us, is this true or false? And then the directions say, if it's false, how could we change this side so that it's true? So let's look through. And the easiest way to look at this for me is to see, what did I multiply by in the numerator and the denominator? If it wasn't one whole, then they're not equivalent. So let's check. 5 times 3 gave me 15. And 4 times 4 gave me 16. So I multiplied the numerator by 3 and the denominator by 4, which means they are not equivalent because I did not multiply the numerator and the denominator by the same thing. So let's check and see how we could make this true. There's two ways I could make this true. I could keep the times 3 and do that in the denominator, and I could get 15/12. That's one way that it would become true. I could also keep the times 4 in the denominator and multiply the numerator times 4, and I would get 20/16. Both of those are correct ways to fix the right side. So I know these are false because this was not equal to 1 whole. In order to find equivalent fractions, I have to multiply the fraction by 1, or a fraction that's equivalent to 1. 3/4 is not the same as 1 whole. Here are two answers I could have changed on the right-hand side to make it true. We're gonna look at two quick ways that we can use division, and then you guys will get plenty of time to practice. So we have this picture here. Right now, the fraction shown would be 2 shaded out of 6 total for 2/6. But we want to make larger pieces. We want to do the opposite of what we did. Instead of making the pieces smaller, we want to see, can I group these differently so I can get larger pieces? But remember, the circles that I'm making either have to be all shaded or all empty. I cannot circle a shaded and an empty together as a group because it's not a group of the same pieces. So keep that in mind as we're working. All right. So I'm gonna look at what are some ways where I could make only shaded pieces together and only unshaded pieces together. So I see I could go like this. And I could make 3 circles. So now I have 3 total, and only one of them had shaded pieces. So do you see that my shaded circles have 1, 2, 3 circles, and one of them was shaded in. So 2/6 is the same as 1/3, and what we did here was instead of multiplying, we divided by 2 over 2. Just like with multiplication, I have to divide the numerator and the denominator by the same thing to keep the fractions equivalent. So I'm dividing by 1 whole because I divided by 2 in the numerator and 2 in the denominator, and 2 halves is equal to 1 whole. I divided by 2 because I made groups of 2. Let's look at one more like that. So I'm going to show you this fraction. I have eighths, and I have 6 of those eighths shaded. So our fraction to start with is 6/8. And again, I want to see what's an equivalent fraction that will have bigger pieces. I have to do all shaded or all unshaded. So I can't do 4/8 and 4/8 because this piece would have 2 shaded, 2 unshaded. But I can do 2/8, 2/8, 2/8, and 2/8. And now I have 4 total pieces. And I have 3 of those shaded. So we say 6/8 is equivalent to 3/4. I divided by 2 over 2, which is what I needed to do because that 2 over 2 is equivalent to 1. 6 divided by 2 gave me 3. 8 divided by 2 gave me 4. And then we have one more to look at. How could I use division to find a fraction that's equivalent to 8/20? So there's a couple options here, but we want to get in the habit, which will prepare us for 5th and 6th grade, of always dividing by the largest number that I can. So sure, here I could divide by 2 over 2, and I could get 4/10. But I could have also divided by a bigger number to make even larger pieces. So if I skip count by 8 and I skip count by 20, I will see that 4 goes into both. So I can divide both of them by 4, which will make my pieces larger. Here I made my pieces as tenths. Here my pieces are going to be fifths. So both of these are correct answers because I divided by 1 whole. But this one is the one that I want to get us in the habit of using because we made the largest units, the largest pieces here. Fifths are bigger pieces than tenths and then 20ths. So again, both correct. This is one that will prepare us for 5th and 6th grade when we're multiplying by the largest possible fraction. Or dividing, sorry, by the largest possible fraction. All right, so as I mentioned before, your independent practice problems are coming straight from the week 5 packet. So if you have the packet, don't do the work twice. Now go start working through the day 1 and day 2 of week 5 packet. Don't worry about my independent practice problems because they're the same. If you don't have the packet, take out a piece of notebook paper, work through my independent practice problems because they're the same as what your friends in the packet are doing. Everybody then should work on the exit ticket because that's not from the packet. So I'm going to go ahead and share my screen. Go ahead and pause here. Take the time to solve these problems. Stay neat, stay organized, do awesome work. And here are your answers. There's more than one right answer to some of these, so that's why I have the or option. You just needed to have one of those answers in order to be correct. And here is your opportunity for an exit ticket. So awesome job today. Proud of all your hard work. I can't wait to see these exit tickets. Think about them like we were at school working in your folder. I want level 4 and 5 work. That means you're showing all the steps. That means you're modeling with pictures if that's helpful to you. If it asks you to use a model, you need to use the model. You're taking your time. You're staying neat. Once you're finished with these 3 problems and you've double checked them, go ahead and have somebody send me a text with a picture and I'll respond as soon as I get it with your grade. Excellent job today. Looking forward to see that hard work. Looking forward to people working in their packets. I've also seen just from Friday such an increase in the amount of people on iReady or Zern. Please remember that every day you should be completing at least 1 lesson on iReady or Zern, your choice. I check both. So keep up the great work. For those of you that read the newsletter, Lonell was our student of the week last week. He did so much work in both math and ELA on all the different websites, completing videos, sending pictures of his work. So he's going to get a special little treat in the mail coming his way. And I look forward to choosing a new student of the week this week. So get working hard, show me that work online, show me that work on the videos and the packet, and get yourself in the running to be student of the week. Keep up the great work. And I will be back Wednesday with another lesson. We'll see most of you tomorrow for a Multiplication Tuesday check-in. We had a lot of fun last week. I'm looking forward to doing another one. So have a fabulous day and work hard, learn a lot. Bye, miss you.